Hi, our scientists. We're wrapping up your unit of study on the hydrosphere. This is Unit 3, Week 2, and we're starting off with a discussion question about water scarcity throughout the world. So take a look at this global map here and then post a paragraph response. And then you're going to also watch a video about water around the world and what if we had no water. And then you're going to respond in your online notebook. Make sure that the response is a paragraph also. So your online notebook for this week looks like this, and you have your video paragraph right here that you're responding to, and then we have vocabulary box with fill in the blank, and then we also have some questions about ocean currents, looking at a couple interactives there, and looking at a website to understand how pollutants can affect watersheds. You're calculating your water footprint, and then you're going to look at water conservation. So make sure you submit your online notebook when you are finished with that. So throughout this week, you're looking at vocabulary and terminology that we have been studying in class. In your 8th grade science class. So this week in this particular unit, in fact, is basically just doubling up that information. So currents are basically going to be continuous movements, continuous flow of water. We're specifically looking at ocean currents, but a current can also be air currents as well, as we've talked about with your unit of study on weather. So it's going to be referring to any type of fluid, whether it is air or ocean. Convection is going to be looking at the density of water. So when you have convection currents form, then that means you have had water that has heated up. So as it heats up, it becomes less dense, so it's going to rise to the surface. And then as that cools down, the density will increase, so then it will sink. So in this case, where this pot of water is boiling, this convection current is created, and that's what circulates that temperature. And waves, so waves in the ocean are going to be formed by wind. So as the wind is blowing, it transfers its energy to the water, and it's moving in this kind of circular pattern. So the particles underwater are moving in a circular pattern, and beneath a certain point, there is no motion of the water molecules based on wind. So you can see that the energy is transferred throughout the water, and as it gets closer to the shore, then there's a little bit of a tilt in the movement of the waves, and as those particles move, then the waves end up crashing on the shore. So waves are going to be caused by wind. So as you look at the breakdown of a wave, the wave movement, as it kind of looks like this, is going to have several different parts to it. So the wave height is the highest point to the lowest point. The lowest point is going to be the trough, and the highest point is going to be the crest. So height is from the crest to the trough, and the wavelength is just from the top of one crest to the next. Upwelling is also something we've looked a lot at in class. So upwelling is going to be when wind blows the warmer water out of the way, and it's warmer water because it is less dense and it's going to be heated by the sun. And as the wind blows that less dense warm water out of the way, then that allows for colder, nutrient-rich water to move upward. And so as that upwelling occurs, it's going to increase fish populations in those areas because it's basically moving the food source upward. So those fish are going to move upward as well because they know all the food is being pushed upward. Saltwater intrusions. So in a salt intrusion is the last new term on here. So a salt intrusion is going to be where you have basically salt water that gets pushed into a freshwater aquifer. So if you have a lot of pumping and removal of water, fresh water from an aquifer through a well, so that is going to be repeatedly removing that fresh water. And if you're at coastal areas especially, that's going to allow for salt water to move into the area. So this is the intrusion that occurs. So not only do you have this fresh water here stored in the aquifer, but now you have salt water that is moving inward. So that's why sometimes at the beach, the water tastes a little bit salty. The fresh water that you drink, like from a water fountain, is going to taste a little bit salty because some Saltwater intrusion naturally occurs, but also if you have, again, a lot of removal, a lot of pumping from wells that is occurring, removing fresh water quicker than the aquifer is recharged by precipitation, then that is going to cause saltwater intrusion to happen, because usually the salt water is going to be flowing out to sea, right? But if you have a lot of pumping removing this water, then that's going to pull in some of the salt water as well. So hopefully that helps you to have a little bit better of an understanding about the vocabulary for this particular week. So oceans, we know already from class that ocean water, salt water, makes up about 97% of Earth's water. So that means only about 3% is fresh water. So of all the water that we have on Earth, only 3% is available to utilize as fresh water. So we're next going to watch this video, this Bill and I video about ocean currents to help you have a little bit better of an understanding about what ocean currents are. And here are the three types of ocean currents that we're looking at. Surface currents, the second one, are the ones starting at the surface of the water. So surface currents are just going to be affected by the wind. So that is going to be kind of the impetus for the surface currents forming. Density currents are going to be further down in the waves. They're further down into the ocean water. And density currents are going to be caused by one of two things, usually either by temperature or by the amount of salt. So it's going to be caused by temperature because we know as water or air, even different types of fluids are heated, they will decrease in density. So warmer water is going to have is going to be less dense. So it's going to be further at the surface, closer to the surface. And if it's something that is going to be colder water, then it's going to have an increased density. It's going to have higher density. So it's going to be found further down. So that difference in temperature is what is going to cause density currents. And density currents can also be caused by the amount of salt, because if water is super salty, like in a brine pool, for example, if the water has a high salinity, then it's going to be more dense. If it's got less salinity, then it is going to be less dense. And then upwelling, we just looked at a second ago. So upwelling is just going to move this cold, nutrient-rich water upward, allowing for increased fish populations at the surface, which is great for fishermen because then they can catch fish and that can make them lots of money. So you're going to take a look at these activities. You can look at one of them or you can look at both of them and help you to have a better understanding about currents and how they flow. And they're going to answer these questions in your online notebook. So that's the section about ocean currents in your notebook. We're watching this video next to understand how currents can influence weather. And we know that warm water is going to cause warm air masses above it, and colder water is going to have colder air above it. So how can humans influence the oceans? So we know that humans can have a big impact on the environment. And as I mentioned just a few minutes ago, sometimes your water at the beach or coastal areas in general, can have a little bit of a salty flavor to them, and that is because of the saltwater intrusion. So here's basically what happens with the saltwater intrusion. So you have wells that are dug down into the ground, right, to move groundwater from a freshwater aquifer. So that's the biggest source of drinking water for the United States is groundwater. So you have lots of wells that are drilled into the ground in a lot of different areas to remove fresh water for a drinking water source for people across the United States. So in coastal areas, if those wells are over pumping, if those wells are being overdrawn and removing too much fresh water, then in coastal areas in particular, some of that salt water is going to get into the groundwater. It's going to get mixed in with that water, and it's going to cause it to be slightly brackish. It's going to cause it to have a low salinity instead of just being fresh water. So that is a big problem, especially at coastal areas where you're using strictly well water. So that is saltwater intrusion into freshwater aquifers. Subsidence is something else that can occur, and this can be due to overdrawing of aquifers. It can also be from compaction of aquifers, so where basically subsidence. Your stem, sub means under. Subsidence is basically where you have the ground kind of start sinking, and it can be causing sinkholes and things like that as well, or just major shifts in infrastructure, like roads and buildings, things like that. So when you have subsidence occur or areas that are really liable to have subsidence, then that can be from compaction of aquifer, from where the ground is kind of compacting, and that can be due to large in part from drilling and from using wells and overdrawing those wells. So here's an example of a result from subsidence. You can see this house is crooked now. So it was not built like that, but now it has occurred as a result of subsidence. Also, this road, so like a part of this road is actually collapsing, and the center of this road is collapsing as well. Dams, this is another way that humans can impact the hydrosphere environment. And we know that hydroelectricity is generated by dams as well, if you're using hydropower as a renewable energy source. So in these areas where you have dams built, it's going to block water on one side and then allow water to pass through on another side. And hydroelectric dams can actually monitor the amount or manage the amount of water that's being let through. So it can let through a lot of water, which it looks like in this case, or can not let through any water. So you're going to have this sort of like man-made reservoir back here, and those can be used for drinking water for a town. And then wastewater treatment plants. So anytime you hear the word wastewater, that's basically referring to poo water. So it can be water that is from toilets. It can be water that's from your dishwasher and your laundry machine. So all the water that is used by humans is wastewater, and it goes somewhere. So where does all that water go? Well, eventually that water is going to be released back into the environment, and a lot of times it's going to have a lot of different things that can pollute groundwater. And so it can have things in it from people, waste from people. It can also have pharmaceutical products, because unfortunately some people dump medicine down the drain or flush it, which you should not do. You should dispose of it properly by going to like the health department or something and asking them to dispose of medicine for you. And also it's going to have chemicals in it, and that could be soap, it can be microplastics. A lot of toothpaste and cleaners have microplastics, which are bad. Detergents, it can have food particles in it, so it can have things that are natural, but it can also have lots of chemicals and pollutants in them. So all of that ends up in our water system, and all of that is going to need to get filtered out, and some of it can get filtered out and some of it just stays. Remember, we talked about you're basically drinking dinosaur pee. All the water we have is all the water we have. So we need wastewater treatment plants to treat the poo water before we drink it again. So water pollution. In your online notebook, you're going to make a list of ways that pollutants can get into our watersheds, and you can take a look at this website to help you have a better understanding of that. There's two types of pollution that we have talked about before in class: point source pollution and non-point source pollution. So point source pollution, you know where it comes from. You literally can point to the source of it. Non-point source pollution, however, you don't know where it came from, and a lot of times it can be from multiple sources and getting all mixed together. We know that agricultural runoff is going to be a big source of non-point source pollution, and agricultural runoff basically is going to be runoff where you have a lot of rain that's basically wiping chemicals from the land or the ground, and that's getting into a river, for example. So that could be fertilizers, pesticides, cow poop, all kinds of things. And urban runoff is another big one as well, and that is in cities. The word urban always refers to cities. So urban runoff, a lot of times it's going to have oil in it. It can have sediment, like dog poop that's been, deposited randomly somewhere. So there's all kinds of different types of non-point source pollution. This example, there's lots of big oil splotches, and if you know exactly where it came from, like this ship is leaking this nasty stuff into the water, then that is point source. However, if it's just big globs of oil in the middle of the ocean, then that's non-point, because you don't know where that came from. And then a lot of times pipes that are dumping water, any kind of nasty water stuff, into a river that or ocean. Like you see these at the beach sometimes. So this wastewater is going to be non-point in most cases because you don't know where this pipe originated. It could have stuff from people's houses from a neighborhood. It could have industrial pollution in it. It can have all kinds of stuff in it, and you don't know. It could have a mixture of stuff. So you're going to calculate your water footprint and then record this information in your online notebook. So you go to this water footprint calculator, it's the Nat Geo website, and just scroll down towards the bottom until you see the water footprint calculator. So you're not going to initially see it at the top of the page, just scroll down a little bit and you'll see it. Your last thing is what can you do discussion. So based on all this information about how humans can impact the environment and the hydrosphere specifically, you're going to write in your online notebook your 5 favorite things that are tips that you can do based on this website. And based on the information that we've studied throughout this particular week module. And then in the discussion, you're just going to share your number 1, your favorite with the class, and explain that and describe how you might begin conserving water at home. So you're just going to go through and look at these tips first, put some of that information in your online notebook, and then just share one of those tips, your favorite one, with the class and how you might be able to conserve water at home. The last thing you're doing this week is taking your Hydrosphere test. That'll be open by Wednesday. It is not open right now, but I will post an announcement so that you will be able to take that at the end of the week. Please make sure you study before you take that. You're only going to have one shot at that test. And also you can use the Quizlet that is posted currently for the Hydrosphere test assignment page. You can use that Quizlet to help you review and then take the test when you're ready.